I hope there's a little bit of overlap with folks that might have seen Andrea's talk in the same place maybe 2 hours ago about her work on making a package to work with the Argentinian census data. I am not the package developer. I'm a package lover and user. And so I'm going to talk about things that I like to use this as like a preview of things you could do with this package. Definitely not a tutorial. I'll start with an overview. And this is about the US Census. I'm very privileged to just say, when I say census, think of the US Census. But there's almost every country has a census. So the census has an API that has tabular data that you can query, and it has all sorts of data. The Census Bureau does not just have the decennial census. It has lots of things. There's something called the American Community Survey, which is done every year, and that's really what I'll be honing in on today, and it has both tabular data and microdata. And the tabular data is very good for when you're wanting estimates at small areas. It already has the estimates calculated, but you're limited to whatever tables they provide, whereas the microdata is person or household level data, and you can do your own custom tabulations, but for disclosure reasons, it's only available at larger geographies. So depending on what you use, it might make sense to use one or the other. And there's lots of other data from the census. And why would you use census data? I'll talk about why I use it, and then why you might want to use it. So I'm a survey statistician, and so I'm often using survey or census data for two primary reasons. Planning my survey, which is like if I'm doing stratification or anything like this, figuring out where my population of interest is in designing my survey or clustering my survey. And then at the back end, creating my post-stratification weights or my non-response weights. So I'm using this data in that sort of way, a very statistical way. I think sociologists and demographers would look at this very different and be using it for different reasons, or if you're just curious about what your community looks like, lots of different reasons. So there's two main packages in R that I use for accessing the census data, and one is simply called Census API, and it is a very simple front end to the Census API, and you can access anything that's on the Census API. The data is not cleaned, which I'll talk a little bit about what that means, and it won't be discussed today. It is, if you need things outside of what's available in tidycensus, go to Census API. But the tidycensus is a bit more opinionated and structured, so it only has access to some of the data, including American Community Survey, ACS, tables, the microdata, decennial tables, so the census, the full census that's done every 10 years, population estimate program tables, which are sort of, they also include projections of where we think the population will be in 10 years, and I think out to 50 years. And then migration flow, where are people moving from and to. This package has nice wrappers. The cleaning that it does, the census has lots of special missing codes, like -5555 means missing. This package converts those to NAs for you right off the bat. You would never want to take a mean with that -555 in your data and be like, why is my mean population a negative number? That could get a little weird. And it gets especially weird if you're looking at stuff like income, because you can have negative income. So the first thing that if you're working with lots of APIs is that you need an API key. The Census Bureau will let you get their data a little bit without an API key, but if you're downloading lots of data, they're going to stop you. An important thing that I want to throw out there, it's a very, very bad practice to store your API key in your code, whether you're sharing it just with your colleague or definitely if you're putting it up on GitHub. So you can install the API key locally to your computer, and these two packages know where to read it from. Just a big heads up, don't put API keys in your code. And then I'm going to talk about the tabular data, a little motivating case from where we are here in Durham, so that you can see what you can get at. So sort of the workflow for getting tabular data is you're going to use this function called load variables to learn what variables are available. And then you're either going to use get ACS, get Decennial, get flow, get estimates, depending on which one you're doing, to actually query the data. And I'm going to start out. Here's our motivating sort of thing that we're looking for right now, given we're on a college campus in Durham, North Carolina. So we're finding the number of I got this wrong, typo. We're finding the number of college students in each census block group in Durham County. And so a census block group is a statistical area. It probably doesn't have much meaning to folks, but it's an area that tends to have 500 to 2,000 people, on average 1,500 people. So it's a relatively small area in an more urban environment. And we're gonna set our year so that we can update this code if we wanted to do this in a future year. And so looking at this load variables, it's a very long table that we get returned that shows us all the variables that we can get from the ACS 5-year data. And it gives us all the variable names that we could query, the labels of those, the concept, and the smallest geography you can get it at. And it's important to understand that, because if you want something at block group, which is the smallest area that's possible with this, and tract is next, you might be looking at a table that won't be available by the block group level. So you have to do a little bit of digging. And if I had way more time, I would show how I do this. It's usually with the capital view function and doing it a bit interactively. But I knew what I was getting at, so I take my data set, I look for a concept that includes school enrollment, I look for the geography being block group, and then all of the variable names are like a table number _1, table name _2, and so on. So I get the table as its own little variable, and I look for what are all of the tables that have school enrollment in them and are available at the block group level. And when I was looking, I settled on using this B14007. We can't see the full thing in here. Again, this is why I'm often when I'm doing this interactively, using viewing in the RStudio viewer. And then I grab out all of those variables, and I see that if I'm looking at variables from B14007, that it includes a variable for the total population, all those enrolled in school, all those enrolled in school by grade level, quite specifically, and then those not enrolled in school. So this looks like a good variable to search for to get where I'm going. And so then code that I'm not showing because it was too much to show in this short talk, I do a little bit of cleaning of that data and make a table where I just have the variable name and a shorter description of it. So that later when I'm querying the data, because it's going to give me the data with just these variable names, which to humans are horrible. Like if I see a variable name that's B14007_009, I have no idea what that means. So this is why I wanted to a little bit contrast with Andrea's tables were made for humans, whereas this is made for computers. And so whether we're making tables for humans or whether we're making tables for computers, you end up with a very different structure. So then, okay, we found the variables we want, and then it's just this little get ACS function to get where we're going. And you tell it which geography level you want. the variables that you want, which are on that table that I saved earlier, what year. I happen to know that the county of Durham is 063 because I live here and I memorize strange things. And I said geometry equals true, which means this is not going to return a data frame. This is going to return to me an SF object, which is great. I'm going to make a map in like 2 steps of this data. So what this returns is, like I said, a SF object, which is a great way to quickly make maps. It has your ID, the name of the area. If you were doing something like at the county level, it would simply have the county level. Block group and tracks are just numbers. Like I said, they don't mean anything. They're just statistical areas. But then it has this column called estimate. That's our estimated number of people that are, what is it? B14007_003. I don't remember what this means. I think those are the first graders. I don't know. It gives us an estimate for the number of people and then a margin of error for the number of people. This is based on a random sample, so it is not, it is an estimate. We must remember these are estimates and not the actual number. So then I can do a little bit of cleaning. SF objects, you can do a lot of stuff that you can do with data or tibbles. A lot of things that you can do with tibbles. So I can join on that names that I had before. So now I know that this variable is those enrolled in nursery school and preschool. So then I can do a little bit of cleaning and just grab those people that are either in college or grad school, summarize them at that GOID, which is that census block group level. And now I finally have the number of people in each block group that are in college or grad school. And we can then make a map of this just in a few steps. And now we know where the college students in Durham are. So where is Duke? Where is Duke? So if you want to know where we are where the yellow spot is, because that is where, there is another college in Durham. It has a lot fewer students, so it doesn't pop up quite as much. So you can very quickly make maps. This is one of the things that I love about tidycensus. And then another thing is the microdata. So for this, you need to identify what your geography of interest is, identify your variables. This is still one of those steps. I would say this is the most labor-intensive step. One of my colleagues last week did try to use ChatGPT to identify the variables, and I identified the wrong variables. And I thought it would actually be good at reading the documentation, but it did not get it right, because that would be such a great thing to hand off. And then you use this get pums to get the microdata. Warning, this data can be large. This is like person level data, and it can be quite large. So we kind of get our variables for this in a similar way. We pull in this pums variables data set. It's not a function. There's a pull request to maybe try to make this a function instead of just a big data frame, because this pums variables actually lives in the package. And then this gives you all the variables. Again, this is microdata. So if you're familiar with working with data, this is more like a data dictionary. So this is telling us that there's the variable division, that we call it division code, and that 0 means Puerto Rico, 1 means New England. So this is a lot more like a data dictionary, but it's giving us all the variables that are possible to query. There's 516 distinct variables on this. I often, actually, there's a PDF version of the data dictionary. I sometimes find that a little easier to work with. Different people have different workflows. For Durham, we want the PUMAs, which are these 2 values. I did have to look this up. I did not know this offhand. PUMAs are public use microdata areas. These are areas in the country that have roughly 100,000 people. So in Durham County, we have 2. LA, Los Angeles County has something like 70 or 80 of them. In Wyoming, they are multiple counties. So it's to make equal level, roughly equal level areas in terms of population. And that you can get this microdata, but you won't be able to see any other types of geography. They're always nested within state, though, so you can always do state level estimates with this. So to pull in the data, these variables are a bit more friendly to the humans. So I pull in from that data the sex, the age, the school. I think this is the school, like the education you've completed, whereas this is the education that you're currently attending. And then a little bit more, and we pull along replicate weights, which are important as a survey statistician. And then you get a microdata. This is a record level. Each record on this represents a person that responded to the survey. For example, we see in Durham that we have 12,665 records. So if you did this for the whole United States, it's going to be big. So if you're trying to do that, there's more clever ways to do this. But if you're just looking for a smaller area, it's pretty manageable. The unmanageable part is actually you're downloading data from the internet. It's not so much the R capability, it's that you are querying data from the internet and pulling it into your computer. So then we have this data. We can quite quickly make an estimate of, let's say we want a very specific thing. The level of school attendance among those who have finished high school that are age 18 to 25. This is not available in one of these tables. So you can make very custom level definitions of what you're wanting to estimate. So I'm getting those that are age 18 to 25, those that 16 is, and if you look at the data dictionary, is those that have finished high school or more, because it's a numeric variable. And then I can then simply do a little summarize. This is using the surveyor package to get my estimates. And then I can then see for each area, so northern Durham and southern Durham, essentially, in northern Durham, 44.7% of people are attending college, whereas 13% are not. And then in southern Durham, 32.6% are attending college out of this specific group. And we end up with standard errors on these estimates. So this is very cool that you can get very niche estimates if you don't need them at a fine-grained geography level. And so I'm going to throw it off to questions. I just kind of wanted to show off this package that's really fun to use, really easy to use, other than finding variable names, and that can get you a lot of data that the Census Bureau is putting out.